So I'm here at White House Machine Tools. We're doing a series of episodes about the Brother series of machines, the BT30 technology, how capable it is. And if you're a BT40 user, you should be looking at these machines because they may be able to offer you considerable savings. One area on what we're talking about today, cutting out the waste, improving or reducing the amount of power you use in your factory and air as a result of this BT30 Brother technology. Dan, it's massively important, isn't it? I mean, it has been even before, power costs went up or electricity went up. How do you achieve it, and what sort of savings can people expect to make using these machines?
Well, yeah, it is important. It's obviously difficult times even at home, etc. So obviously, being in a manufacturing business, everything's tenfold essentially. So the Brother product, with its dynamics and its technology, really harnesses the waste and effectively decreases the actual costings.
And how can you quantify it? I mean, let's take a general machine shop using a BT40 machine. As we've said in other episodes which are available on our YouTube channel, if you take a program out of that machine and put it in yours, okay, you reduce the cycle time by, maybe half or whatever the numbers are. How do you then show them or demonstrate that you can also save energy? And how does it compare?
Yeah, so we've got applications out on the field that have done comparisons on 40 taper machines against our 30 product. And we obviously are seeing the cost savings on the actual power consumption of the machine. The Brother actually showcases that in on the actual control, so you can see its usage, the voltages used over a certain time. So it's just like looking at your usage on your electric bill at home.
And is there a way of reducing it or illustrating it in pounds and pence? Because people want to know, my BT40 machine, over the course of a year, it cost me 10 grand in electricity or whatever it might be. How could you compare it? And could you say that 10 would now be 5 or that 10 would be 3? Or
I suppose it's harder to put a figure on it. You would use the cost of power. Essentially, you would be able to extract all the information from the actual Brother control, and then you'd be able to do a comparison of like for like between the 40 and the 30. But yeah, you will expect to see a big saving on the power consumption because you're not traversing the mass.
And is that the reasons? That was my next question. How do you do it then? How do you do it? Let's say, I've seen figures of, they seem outrageous, 80-90% saving in power consumption. I mean, how are you achieving that?
Well, yeah, first of all, one big aspect is the mass. You're not traversing a big old lump. So effectively, you're not moving. Your linear rails are not affected by the actual weight of traversing all the material, and effectively, the machine has a special technology. We'll also cover it in the PowerPoint, that it harnesses that power back, similar to an F1 style car. So then, as it slows down, it pulls that power back, it puts it back into the actual inverter technology, and then it applies that. So when it accelerates, you're using that wasted power.
So you're kind of saving energy and then using it again.
Yeah, that's it. Yeah.
You're almost like recycling it. I guess.
Effectively, you are. Yeah.
Okay. Now that's the power. Then there's another one that's really important. And again, if you're a BT40 user, you really should be considering some of these aspects. What this BT30 technology can now do. Air.
Yes.
Now where are you using air on these BT30 Brother machines compared to BT40? Where's the saving and how much is the saving?
Yeah, so the machine isn't reliant on air so much as the BT40 foundations. For instance, one thing to point out is the tool changer is actually a mechanical tool changer, so it's effectively like a cam system. So it releases the tool and the pull stud by driving the spindle up through a cam, which releases the pull, and then when it reloads the tool, it then mechanically loads it. So just those little wins effectively equal to a big old saving when you're running it across the year in production.
How significant is the two areas we've spoken about, the power and the air? How many customers have you been into? How many customers have you supplied to that you're now talking to and they're going, the reduction in consumption is just unbelievable?
So the power one is the main topic. I suppose air is disconsidered in the manufacturing environment a little bit more, but the power is definitely one that they can focus on. You can extract information from the Brother control easily. So then when you're comparing with a software that keeps an eye on the spindle running time and etc. And then you've got the power consumption. You can put those two in a graph, and then you can see the savings of what you expect.